Hello students, how are you all? I am back once again. Today we will study distance time graph. We all have studied the graphs in our previous classes also. So there is one type of graph that is known as line graph. And for this distance time graph, we generally use this line graph. Basically, graphs are of bar graph, pie chart, histogram, line graph. So, but for distance time graph, we will use the line graph. In this, we will take on x-axis the time and on y-axis the distance. So I have just supposed that in 0 seconds my distance is also 0, 1 second 5, 2 seconds 10, 3 15, 4 20, 5 25. You can see that these both are in regular interval, means here 1 second is increasing, here distance is increasing with a multiple of 5. So what will happen in this case? I have taken this graph. This is my x coordinate and this is my y coordinate. In my x coordinate I have taken the time. Here I will write also that this is the time, and on my y coordinate I have taken distance. So for 1 it was 5, 2 it was 10, 3 it was 15, 4 20, 5 25. Then I have joined all these points and then I have joined it with the origin. So this is how we make a distance time graph. And one thing more we have to remember, that always we have to draw the graph with a pencil, not like this with a pen. I have drawn here with a pen just to tell you that this is wrong. We have to draw with a pencil. So what are the general points that we have to take into consideration when we are drawing any graph? Draw a line OX. So this line OX is perpendicular to OY, means it is making an angle of 90 degree, and O will be an origin because over here x-axis and y-axis are meeting. O as the origin, OX as the x-axis and OY as the y-axis. After that we have to take a scale, means we have to take distance, how much centimeters we will divide it equally our graph into. So here I have taken 1 centimeter is equal to 1 second on my x-axis and 1 centimeter is equal to 5 meter on my y-axis. Here it is 1 second, here it is 5 meter. 1 centimeter, if this like I have drawn with the help of a normal paper, but if we are drawing on a graph, then 1 centimeter of one box if it is on a graph paper. Anything you can take as per your convenience. Then we have to mark the values of time and distance. Like here I have marked the values of time, here I have marked the values of distance, which was given previously in my question, that I am taking these values to draw my graph. From the table draw the points, then we will mark the points, join all the points and it will be a straight line. When we have joined, this is a straight line. So what does this conclude? Distance time graph of a body moving with constant speed is a straight line, and if it does not move with a constant speed, then it will not be a straight line. It means like here it was a constant speed, means time was also equal interval and distance was also an equal interval. That is why it's a straight line. But in case if either time is unequal or distance is unequal, that time we will not get this line as a straight line. Understood? Next is how to choose scale for a graph. Like here I have taken 1 centimeter is equal to 1 second, 1 centimeter is equal to 5 meter. How I got to know that I have to take the scale like this? So following points needs to be taken care. Difference between the highest and the lowest value of the quantity. So what was the difference between both the highest and the lowest? It was 20. intermediate values so that they should be plotted easily with the scale chosen. So what was the gap in between all this? I've seen this. So here it was 5, here it was 5, here it was 5, here it was 5, here it was 1 and 1. Utilization of maximum part of the graph. So here my maximum part of the graph will be covered. So these are the 3 points which we have to take into consideration whenever we are choosing the scale of a graph, because if it is unequal, a graph will not be a correct. If say for example here I have taken 5, here instead of 10 I will take 15, then here I am taking 20, here I am taking 30. So the scale is not proper, that is why my graph will also be not correct. So scale should be correct for a graph to be correct. So this is one of the most important thing whenever we plot any of the graph, whether it is for a constant speed, whether it is for a non-constant speed. For both we should take this thing into consideration. Next is velocity. It is the speed of a body in a particular direction. Example, 15 meter per second due east. So here I know that my body is traveling in the east direction. Speed is same, that is 15 meter per second. But when I got to know the direction also, that time it is velocity. And if I do not know the direction, that time it is speed. So there are again uniform velocity. When a body moves with a uniform speed in a specified direction, when magnitude as well as direction is same. Example, aeroplane moving at speed of 400 km per hour due west. So whenever my body is moving in a uniform speed, means equal interval in equal distance, and the direction is also specified, that whether I am moving in north, south, east or west, whichever direction it is asking, I am moving in the same direction, that time it is a uniform velocity. Variable velocity, when magnitude of speed or direction changes, means if a car moving by applying brakes and changing direction, like whenever we are going in the market, that time constantly we have to apply brakes. कभी कुछ आ जाता है बीच में, कभी ट्रैफिक जैम हो जाता है, कभी कोई पर्सन आ जाता है, कभी रेलवे क्रॉसिंग बंद होती है, कोई सी भी रीज़न के कारण हमें ब्रेक्स लगानी पड़ती हैं. जब भी हम वो ब्रेक्स लगाते हैं तो हमारी स्पीड चेंज होती है. और whenever we are taking a U-turn or whenever we are going into any street, changing the direction, that is a variable velocity. Average velocity, ratio of total displacement to total time taken. तो जितनी हमारी total displacement है, why I have taken over here displacement? Because distance is not having direction, but displacement is having direction. That is why in velocity we have to take displacement, not the distance, because velocity is measured with the help of a because whenever we are measuring the velocity, we are telling the direction as well. So that is why it is total displacement upon total time taken. Then it is acceleration, change in velocity of a body per unit time. Means जो हमारी change हो रहा है body में और with respect to time, that is acceleration. Change in velocity upon time means हमारी velocity पहले जब हमारी body शुरू हुई थी उस टाइम पे कितनी velocity थी, और जब ख़त्म हुई है, stop लगा है हमारी किसी body का, उस टाइम पे कितनी velocity है. That is change in velocity. That is final velocity minus initial velocity upon time. Final velocity is denoted by V and initial velocity is denoted by U. Time is denoted by T and acceleration is denoted by A. So we can write it like this also. A is equal to V minus U upon T, and if I cross multiply this, A into T is equal to V minus U. V I have taken it this side, or else I will keep it like this only. I will bring U this side. V is equal to U plus AT. This is my equation by which if I am having the final velocity, if I want to find the final velocity, and if I know the initial velocity, acceleration due to time and time, acceleration due to gravity and time, I can find my final velocity. If I want to find the initial velocity, that also can be founded. Any of the things can be founded if three things are known to me. SI unit of acceleration due to gravity is meter per second square, centimeter per second square, kilometer per hour square. When a body is thrown from a certain height, it moves down due to ग्रेविटेशनल फोर्स. मतलब अगर मैं किसी भी चीज़ को नीचे ऐसे फेंकती हूँ, वो नीचे कैसे आएगी? क्योंकि अर्थ की ग्रेविटी उसको अपनी तरफ पुल करेगी. सो ऑन एन एवरेज, आई हैव ऑलरेडी टोल्ड यू इन द लास्ट क्लास ऑल्सो दैट आर एवरेज एक्सेलरेशन ड्यू टू ग्रेविटी इज 9.8 मीटर पर सेकेंड स्क्वायर. You can take it as 10 meter per second square also for your numericals, but you have to specify this thing. Next is the simple pendulum. In simple pendulum, our first term is, I have already shown you the simple pendulum. So first we will discuss about amplitude. Maximum displacement of bob of simple pendulum from its mean position. मतलब वो कितनी displacement कर रहा है अपनी mean position से, that is the amplitude. Length of pendulum, distance between the point of suspension and midpoint of bob. मतलब जो ये है point of suspension और जो हमारा midpoint है bob का, मतलब जो ये bob का है यहाँ पे, this is the length of a pendulum. Next is the frequency. It is denoted by the symbol n. Number of oscillations made by pendulum in 1 second. मतलब एक सेकेंड में वो कितनी oscillations करते हैं, that is the frequency. SI unit of frequency is hertz. It is denoted by capital H and small z. If you want to write the full, then it will be all small, but symbol is capital H and small z. Next is the seconds pendulum, whose time period is 2 seconds. मतलब जो सिंपल पेंडुलम जिसका टाइम पीरियड 2 सेकेंड है, दैट इज नोन एज सेकेंड्स पेंडुलम. टाइम पीरियड t इज इक्वल टू 2 pi root L upon G. Time period is T, 2 pi root L. L is the length of simple pendulum. G is the acceleration due to gravity. You can see T is directly proportional to square root of L also. If time period increases or decreases with change in length, मतलब time period हमारा increase भी कर सकता है, decrease भी कर सकता है अगर हम उसकी length में कोई भी change कर देते हैं. And it is inversely proportional to square root of 1 upon G. Understood? I hope you all have understood the chapter till here. If you have any doubts, call me anytime. Thank you.